Evening, and thank you for joining us today. We're starting on time today for special reasons we will explain. But yes, this is Local Talks, and it's the third session we've had this year. Local Talks is a series of events around green design. And today we have the topic of green prefabs, so accelerating growth without destroying the planet. And we have three speakers that have joined us. We have Nishal Pradhan. We also have Wolf Barons and Felix Holland. Nishal is going to join us online, and then Felix and Wolf will be joining us both in person here. We have an audience online. You can all see each other, and we also have an audience in the crowd. Hopefully you can see through the camera called Crichton. So thank you for joining us, and thank you to our speakers for being here today. We have a little bit of a slightly different program. Usually we have all the presentations and then we'll have a Q&A. But today we'll start with Nishal's presentation, followed by a Q&A, and then afterwards we will have Felix and Wolf and a second Q&A. Nishal is joining us from the Philippines, and so his time zone is quite different from us, and it would be easiest if he goes first. So yes, we're grateful to him for his time. Especially as he's joining us quite late. So I think we will start. I'll give a short bio summary about each speaker before they speak so that you know a little bit more about them. And then just also to let you know, this is being recorded and will be uploaded to our YouTube channel, so you can watch it after this event. After a few days, we typically upload it. And yeah, if people have questions, you can also, if you're online, you can put them in the chat or in the Q&A during the session, and then we'll answer them during the Q&A time. So let me move into the bio. So Nishal Pradhan and his bachelor's degree in civil engineering, graduating at the top of his class from the National Institute of Technology in Warangai. He completed his PhD in civil engineering with a focus on bamboo connections at the Hong Kong University of Science and Technology. After graduation, he worked as a consultant to Base Bahay Foundation in Nepal. He has assisted Habitat for Humanity Nepal drafting Nepalese bamboo construction guidelines and piloted experimental characterization of Nepal bamboo species. As the director of the Base Innovation Center, Nishal oversees research and development, the writing of codes and standards, structural design, and the management of external partnerships. So let me hand over to Nishal.
Thank you, Randy. Glad to be here. Good evening to all of you. So if I may, I'll just share my screen. Just give me a second. Can you see my presentation?
Yes, yep, we can see.
Okay, so thank you for giving me this opportunity to present our work. So for the next 20 minutes or so, I will just briefly introduce you to what Base Bahay Foundation has been doing in the Philippines. Before we start into the details, I'd like to make a few statements here in that, you know, globally, we have about 1.6 billion shortage of housing. And to make that requirement, we have to build at least 96,000 new houses every day. And also, if you look into the cities worldwide, I would say 80% of the cities do not have an affordable housing options for the population. Within Philippines, we have a shortfall of about 6.5 million houses at the moment. And this number is expected to go up to 22 million. And you know, Philippines is actually a very country that's a very susceptible to natural hazards, right? So we have earthquakes, we have typhoons, you know, and specifically in terms of typhoons, we get around 22 typhoons every year, right? So and every year we get. And this typhoon will give you a damage of over 305,000, 100,000 homes that have been damaged every year. And within this context, if you look at the built environment, the building and construction environment, you can see that globally, it contributes to about 37% of CO2 emissions. And in terms of energy utilized, it uses more than 34% of total energy consumed. Right now, you have to remember that the energy that has been consumed mostly in the world is mostly generated by fossil fuels, and this is the reason why we see such a large contribution of CO2 by the building and construction sector. Now, here, given these challenges, we make a proposition that we think bamboo is a very strong contender to help us achieve socialized housing, um, similarly to what timber has done for the global north, right? So we think bamboo will help us achieve this our goal of building sustainable housing in the global south beyond Philippines as well. And the reason why we think bamboo is a top contender is because it's a sustainable material. It provides livelihood to farmers that grow them. It has a natural in its natural habitat. It protects soil from erosion. It protects the land from flooding. And if you plant bamboo in a plantation, it will be ready for harvest within 3 years of growth, and you can harvest bamboo poles every year henceforth. If you compare to a conventional conventional structural material, for example, cement hollow blocks, we see that our houses have about 60% less carbon footprint. And bamboo as a natural material, as a hollow material, we have we have seen a more comfortable indoor climate in houses that we build. Base Bahay Foundation actually was established in 2014 as a means to provide sustainable housing in the Philippines. So we have like three different main pillars. Of the first pillar consists of Base Innovates, where we research and develop the technology that we use for our construction. So this is a precursor or the type of housing that we build in the Philippines. We have another pillar we call as Base Enables, and here we provide our partners, for example, contractors, beneficiaries, bamboo harvesters, chemical treatment, bamboo treatment plants, with the necessary technical know-how and knowledge to help them achieve their own construction using bamboo. And finally, we also have a pillar where we build sustainable houses directly for the underprivileged in the Philippines. The technology that we're talking about is called a cement bamboo frame technology. And this is not a new technology. Actually, this existed in the form of Bahareque structures in Colombia over 100 to 200 years ago. And we brought this technology to Philippines. We modified a little bit, made it suitable for Philippine environment, and we gave it a different name because this technology, cement bamboo frame technology, is not exactly same as the Bahareque. We have some differences. So we can say that this structural system is typhoon resistant, earthquake resistant, fire resistant, and also insect resistant. So we actually did a real life test to see how these houses fared against typhoon. So we built this three nearly identical models of CBFT houses in one of the areas that is very frequently visited by typhoon. And in the same year when we built this house, a super typhoon called Typhoon Glenda passed through it. We had installed a weather recorder that measured wind speeds up to 220 kilometers per hour, and this is the photo after the typhoon. And we went there to check it out, and we saw that the weather stations was blown away. We were never able to find it, but we can see that the houses are all standing with minimal damage. Maybe some damage to the roofing because we didn't really tighten those areas properly. But I mean, it's overall very safe, no damage whatsoever structurally. On the other hand, you can see that we also built a traditional bamboo structure using traditional techniques, and you can see that this house didn't make it. So what this tells you is that the houses, I mean, that has been built by bamboo, right? So the bamboo material as a material is not the problem. What is the problem is that there is a lack of technology in building the correct way, right? So with this, I'd like to show you how we built our CBFT houses. So for the first, we built the foundation. So this is the foundation is conventional, using conventional materials, for example, reinforced concrete beams, hollow earth blocks, and also um, um, uh, traditional backfilling methods. So the plain slab can be plain cement concrete. You do not need to reinforce it. Even though here you see us using the rebars. And once the foundation is done, we can just slot the cement bamboo frame elements onto the structure. Once you have installed the panels, then we start putting in the roof framing and the roof cover. The idea here is that once we provide the roof cover, we protect the bamboo poles from further deterioration under the sun. And once we have the shade, we can take our time putting in the matrix and cement mortar cladding. And finally, we install the doors and windows and then provide finishing. So this is how the typical construction process happens of our social houses. Right now, the advantage of this construction practice is that our construction is focusing on prefabrication, right? So the wall panels that you saw in the video are all prefabricated in a bamboo treatment site, or in specific cases where we have large construction project, we can also prefabricate in the field. Now, the total time taken for construction from start to finish is about 6 weeks. So the foundation works and the prefabrication work can happen at the same time. So to completely finish the foundation, it takes about 2 weeks, and it takes about 1 week to prepare all the panels, the bamboo panels for the superstructure. So once you have prefabricated all the panels, you can transfer it to the site, and the installation of the panels on the site takes about half a week. So let's say 2 to 3 days. Actually, just installing the bamboo frame elements onto the site takes only a matter of 2 to 3 hours. So the rest of the time is taken in aligning those panels properly, ensuring that the corners are perpendicular, the panels are vertical and along the plumb. And once the panel has been installed and aligned properly, we proceed to roofing, and that roofing takes about another half a week, so 2 more days. Once you're done with roofing, we spend the next 2 weeks doing the cladding. Here, the cladding consists of cement mortar render, which we apply in 2 coats. The first layer is a rough layer, which we allow to dry, and then we do a final layer that is finished and painted over. So the process of finishing the bamboo house, the cement CBFT house, takes about 1 week, and in total, from start to finish, it's about 6 weeks. So this is how a finished social house looks like. And you can see from the outside, it looks just like any other conventional building. But then when you go inside, then you can see that the structural system is all bamboo, and you can see how it differs from conventional houses. So here you can see that there are two types of CBFT system that we use. The one on the left side uses flattened bamboo as a wall matrix, whereby you have the initial round pole that we open up, and that serves as a bed for cement mortar plaster on the outside. So this one gives you a more natural finish on the inside of the room. You can also use, instead of flattened bamboo, or more of a steel riblath, a steel mesh. And this one, you can also see that you have to have mortar finishing on the inside as well. So from the outside, it looks just like any other building. No, you wouldn't know that this is a bamboo structure. We have used this technology to build a lot of houses in the Philippines. So these are more of a special structure for a one-off projects, but most of this houses that we build are kind of single, detached, or duplex types social houses. We also have two-story buildings that you can see here, and this one is actually built by our partner. So this is his home. Actually, our partner's company is called Kawayan Collective, and the owner of the Kawayan Collective built this as his own home. We have also used the technology to build larger structures, for example, a community center, school building, even production facilities such as weaving centers and food processing centers, and marketplaces and offices. In total, we built about over 2,300 homes in Philippines, Nepal, India, and Nicaragua combined. Now, within Philippines, we've established 7 bamboo supply facilities, actually 7 treatment centers, and 1 more treatment center is being constructed near Manila this year. So all of these treatment centers provide high quality construction grade bamboo poles to all of our construction projects. Together, since if you count all the houses, we have saved over 30,000 tons of carbon dioxide. So that amounts to about 12 tons of carbon dioxide per house. We have provided shelters to more than 10,000 people in Philippines, and also in Nepal, India, and Nicaragua. And we have trained over 2,000 workers. We have also provided over permanent jobs to over 1,500 people directly. So now, besides construction, our pillar or the arm of the company called is the Base Innovation Center, and this is a lab that supplies all the technology, develops all the methods, does all the research to enable us to build such houses. Now, the Base Innovation Center has 3 specific tasks. The first one is conventional research and development, where we develop new technology. The second one is to provide training and learning, where we do transfer of technology to our partners or bamboo stakeholders who are interested in building with bamboo, and also providing expertise in terms of CBFT construction, setting of treatment plans, and also teaching them how to treat properly. So inside the Base Innovation Center, all of our research are mainly encompassed in 3 key areas. The first one involves characterization of the material, where we do large-scale material strength tests to understand the behavior, right? So the data that we collect from material tests is used for structural design of bamboo houses. We are also looking at a structural element level, and in particular, trying to understand how connections behave. And in the global scale, we are also doing wall panel testing to understand how the walls are to understand how the walls behave under wind and seismic loads. So all of the data that we generate from the lab is used for design and continuously improving our technology. And our research is supported by a network of local and international universities. So the local universities, we have about 7 nearby universities that provides with bachelor student, master student, and also PhD level student. So they spend they spend their time in the Base Innovation Center and do their respective thesis work. We also have a partnership with international universities that provides complementary skills, complementary knowledge, and complementary technical expertise to our knowledge in base. We are partnering with other institutions besides universities to help us deliver the technology we develop in Base Innovation Center into the field. This includes ARUP, Habitat for Humanity Nepal, INBAR, and other companies. So here I show you some basic examples of tests that we have been doing over the past year. So compression test, tension test, bending, shear, and shear perpendicular. So tension perpendicular, right? And these are reference values that we've calculated. These are a few examples of connection tests that we've done in the Base Innovation Center. And this is an example of shear wall test in action that we've done. So you can see that we apply the force at the top, and then you can see how the wall is deforming under the lateral loads. Yep. So here, that's the end of my presentation, and yeah, I'm open to any questions. So back to you, Randy.
Thank you, Nisha, for your presentation. It's really very interesting. I think we will, as I'd explained at the beginning, I wanted to open up for Q&A specifically for Nisha and the Base Bahay Foundation and the work he's doing. So if you would have, if are open to our audience first, and then people online as well, you're welcome to use the chat. We can see that and ask on your behalf. So I think I will hand over the microphone if you do have a question. All right.
Hey, Javon.
Hi, thank you for your presentation. My name is Paul. My quick question is to do with the bamboo. Do you treat it in any special way, especially where the buildings are in high precipitation areas? And what is your experience? You know, are the structures affected in any way that is different from places where there is much less precipitation? Thank you.
So that's a good question, Paul. Now, I would say yes, we are treating all of our bamboo poles, and treatment is mandatory actually, because we want the bamboo poles to be protected from insects and fungus, right? So the chemicals that we use for treating is called solignum, and it's originally used for wood. And I understand that this is a proprietary chemical that that is used exclusively in Philippines. But if you look globally, you can also get similar results with boric acid and borax solution, and and by far that chemical is the most common all over the world, right? So the chemical that we're using actually allows us to shorten the chemical treatment process. So we use soaking method, where we soak the bamboo columns, immerse it into the solution for about 16 hours, and that will enable us the bamboo poles to be sufficiently resistant to insect and fungus. Now this soak immersion is just a part of the one part of the treatment. We also have a series of pre-treatment processes that involves grading the bamboo columns, discarding unviable defective poles, cleaning it, pre-soaking it into another treatment tank where we want to remove the starch, and also sun and air drying processes in between. So this treatment process is also more comprehensive for our case, and so far I think we haven't had a serious insect attack in any of our houses and treatment centers. So like maybe a small percentage, maybe less than 1% of bamboo poles that we use are infected by insects. Now, coming back to the question of high precipitation area, yes, the bamboo poles can be used in high precipitation areas, provided that bamboo poles are covered or protected from rain. So, and here in this case, you have to realize that Philippines is one of those areas where we have very large amount of rainfall every year. On top of that, we also have typhoons that and high winds that come with that rain, right? So one way to protect bamboo from getting damaged is to clad it. And here, the bamboo frame, the cement mortar cladding plays into the role and protects the bamboo pole from damage. I hope I answered your question.
Hi, Nishal. My name is Felix. I have two questions for you.
Yep.
One is quite a simple one. What's the detail of fixing the roof sheets? Bamboo poles are very irregular by nature, and how do you fix to it a metal sheet in a practical way? That's the first question. The second question is a bit more complicated. It's about thermal mass and indoor climate in these spaces. I'm sure you have done some bit of studies and some bit of testing around humidity levels and temperature levels on the inside. Of course, your walls are incredibly thin. I don't know how thin, but it's more like a ferro cement wall, right? Similar to that. And a cementitious plaster also has the tendency of not allowing humidity to pass through. So are the humidity levels not very high on the inside of these spaces? And how is the indoor temperature?
Okay, so your first question about roofing. So the roofing purlins that you saw in the video. Okay, so the video is a bit old process, right? So where we individually put the purlin. Now we have a better process that we have adopted in our construction, where we prefabricate the roof purlins as well. So the roof purlins are installed as a prefabricated panel system, and then whereby the bamboo poles are spaced very regularly, right? So this allows us to have a greater control over the drilling procedures for installing the roofing sheets. Also, you have to realize that the bamboo poles that we use for construction have been graded. So we have removed all the poles that have a large geometric variability, so the ones with out of straightness imperfections, for example, they have been removed. So these processes help us achieve very good tolerances and accuracy while installing the roofing. Now, the second question, could you repeat it again, please? I kind of lost you for the second.
It was around indoor climate.
Okay, got it.
Thermal qualities.
Yep. Yeah, I got it. So we did some tests with the thermal comfort studies. So it's also under process. So what I can tell you at this moment is, compared to the nearest conventional technology, for example, cement blocks. So I think during the daytime it is comparable. The performance is comparable, but in the nighttime the CBFT structure is better. So that's what my colleagues tell me from the study that they are doing. Now, what I'm trying to say here is, now even if the cladding is mortar, right? So we have a layer of flattened bamboo sheets that separates the mortar from the indoor area, right? And also bamboo is a hollow element, right? So because of these two reasons, actually we have a quite huge gap. Actually, the heat does not really transfer from outside to inside very quickly. So in a given hot day, you can find that our houses are quite cooler than outside. I would say by about more than 5 degrees in a very hot day. If hope I answered your question.
Yes, thank you.
Thank you. Hi, Nishal. My name is Sophie.
Hi.
I have a question regarding the species. You just mentioned that the bamboo you're using is hollow. I found some bamboos to be quite thick, almost without the little space in the middle. When you're doing your tests, what is there a particular species that you stick to, or is there one that's best for construction, or is this depending on like the different regions that you work in?
So the answer here is the species that we are using is dependent on the regions we are working in. Now, the species that we use most commonly is Bamboo sublumiana. So that species is available throughout the Philippines. That's the most common species, and that is the bamboo that we use for most of our construction, right? Besides that, we also have other species, for example, Dendrocalamus asper, Bambusa vulgaris, and also Guadua species that originally came from South America. So a few of our partners in the southern region of Philippines use alternate species, these three species, and we have been doing experimental testing and characterization of species so that we can also start using them in construction.
Okay, thank you.
Yeah.
Hello, thank you for the presentation. My name is Guy, and I have a question concerning the fire performance of the bamboo buildings, especially in surfaces where the bamboo is exposed. How are you able to meet the minimum requirements?
Okay, that's a good question. So I need to open my slide again. Just give me a second. Yeah, okay. So here, if you look into this figure, right, you can see that there is a projection between the house, right, in the center, right? So this is a duplex type house, right? So this is a duplex type. This is a duplex type house, and we have a projection here. Oops, sorry. So we have a projection here. Now, this projection is actually fire rated for about 2 hours, right? So if this side is under fire, the fire will not travel through this wall and make the other side catch fire as well. So by the fire safety law within Philippines, only this wall that is supposed to be to have 2 hours of fire rating. The rest of the structure need not necessarily have fire rating performance. If I is that what you were asking, sir?
Yes, it is. Kind of answers my question.
Yep. Now, what I can tell you a bit more, if you want a bit more detail, we have a very specific configuration of wall that allows us to reach 120 fire elements, and it is not this one. So this one uses, for example, flattened bamboo, right? So here, what we found out in our fire testing was that these flattened bamboo matrix can catch fire very quickly, let's say within 1 hour. But if you use, instead of flattened bamboo, if you use a steel riblat meshing and then use mortar cladding with that, then you can get the 2-hour rating. Okay. Back to you, Randy.
I think so.
Hello? Sorry, I can't hear you.
All right, I think we're now back. I think that, so the questions in the audience, I think we've now completed that section and we can move on. We had one more sort of question in the chat about generally how technology of bamboo is not as popular, I guess, as used in the global south. I think it's probably referring to the continent of African continent as opposed to where you are. And so the question is maybe how can we have, I don't know, more access to technology or learning about bamboo? Or is there any encouragement you have? Maybe you've seen bamboo used more and that kind of thing. I think some sort of cross learning, that question.
Yeah, okay, so that's a valid point, So unlike conventional materials, we don't have sufficient technical research or knowledge on building with bamboo, right? So what I can suggest here is we look at those countries where bamboo construction is already existing. And one of those countries is Colombia, and they have their own bamboo construction standard. So that could be a starting point for you to get into bamboo construction. A second point here is Base Bahay Foundation has been thinking about conducting online, globally accessible online CPD training for bamboo construction. And when we make this feature online, maybe you guys can join in and have and take part in those courses as well.
Yeah.
So that could give you a very good starting knowledge to build with bamboo.
Definitely. Great. I think it would be good to connect more in the future. So thank you very much, Nishal, for joining us. We'll let you leave as we continue the rest of the presentation, but you're welcome to watch it online later. And if there are questions that follow for you, we will share them. But thank you very much.
Thank you. Bye-bye.
Next, we will have Wolf Byrons give us a presentation. He's in our audience, and we might need to turn the camera. I don't know if Crichton, you could readjust while let me just do this. I think you will stand here so that you can, let me just, the full screen again. Nice to meet you. That one. Okay. So you can use this. I'm going to give a very short introduction. Your profile so that everyone knows who you are. So Wolf Byrons, who's standing next to me, is an impact entrepreneur and an engineer in environmental technology, circular economy, and bio-based construction. He founded Easy Housing in 2020 with a mission to make sustainable, affordable housing accessible in emerging economies by building circular and bio-based homes. He founded the Dutch scale-up Sustainer in 2015 and was CTO of that until 2020. He is listed under Forbes 30 under 30, 2017, and in Dutch Sustainable Young 100, 2016 to 2020, and is an MIT solver. this brief bio, I will hand over to him.
Thanks for the intro. Good evening, everyone. So my name is Paul, founder of Easy Housing. Happy to be here with you, some familiar faces, and excited to hear the pitch of the previous speaker on the amazing bamboo works in the Philippines. We also have an emerging bamboo ecosystem in Uganda by some friends of ours in Salt Bamboo, Uganda. So there is some potential for bamboo construction here as well. But it's also interesting to highlight the differences between bamboo frame construction and timber frame construction. What we are doing at Easy Housing, as one of the first ones in Uganda, I think. Interesting difference culturally is that bamboo is much more accepted in Asia for construction, and timber is not really accepted for construction in Uganda, but you can make it look rather ordinary inside and outside if you want. But it makes it easier to introduce prefab timber in Uganda as compared to prefab bamboo, I would say. But yes, let me just move into the presentation. Is this now being shared to the?
Yeah.
All right. This one?
I forgot to do that part. There we go. Yes, it is being shared now. Thank you for asking.
Yeah, so we definitely have not yet built 2,000 homes yet. So I thought that was an amazing, an impressive figure. We are more around 30 units now, I believe. So with current prospects, it's looking good for high-based construction in Uganda, I would say. For us, I think next year we'll scale up to around 100 homes per year. This is a recently finished holiday home in Western Uganda near Fort Portal. One of our larger standard models, I would say, 4 bedrooms with a clerestory roof, veranda. And yeah, I can go into the specifics of the construction a bit later. I think it's one of the cooler projects we've completed so far because generally the aesthetics of it. Then, how do I now go to the next one? Yes, there we go. So our core values at Easy Housing are sustainable, social, and scalable. I think the sustainability around bio-based and circular construction is probably known to most of you. Our proprietary prefab building system is fully circular, so all the connection details are within the design principles of the circular economy. All elements can be taken apart, reused, repurposed, relocated if you want. Another important aspect of green aspect of building with prefab timber here is that zero carbon solution, or even better than that, because the timber is bio-based material, stores carbon in its structure, which amounts to around 10 tons of carbon storage in an average home. That is quite a lot of carbon storage. And next to that, also a lot of carbon avoidance by not using conventional materials. Another important aspect of the sustainability, but also of the scalability of our approach is the localized value chains using locally sourced sustainable timber from FSC certified plantation forests near Jinja, Soga Forestry. And most of the materials and labor also sourced from around Kampala or from Uganda. Then, of course, the social aspect, but I won't go into that too much. But timber homes are generally experienced by inhabitants as being very comfortable, healthy, have good aesthetics, if you like timber, and so on. And what is most important about our approach, I believe, is the scalability of the concept. Where let me see if the audience can hear me, by the way, because it's behind the thingy. is the scalability of the concept. So through prefabrication, you can actually have a centralized production facility. We have a factory in Kampala. We opened a new factory around half a year ago, which has the capacity for around 10 homes per month within the factory. And we can replicate that model to new locations. And that centralized approach and the advantages of prefab allow for the scalability. I'll tell a bit more about that later on. So these are our core values. We started in 2020 as a concept, trying to figure out which locations would be conducive for us to try and introduce prefab timber. And we found Uganda a very good country to test and to see if we could introduce it into the market. For various reasons, Uganda has a good sustainable forestry sector, has a good climate for timber construction. It has a large housing gap, although that's the case for most countries, actually. And we thought culturally it would be feasible to introduce the concept. So that's why we focused on Uganda, and actually since a year ago, we have been really scaling up our marketing efforts in Uganda, which after also a pivot from B2B to a B2C approach to directly targeting potential clients that have a piece of land somewhere that they want to develop. That was a very important pivot, which resulted in us surviving and thriving, hopefully. So these are the countries that we have been operating in, although Uganda is the only one where we are actually scaling up at the moment. We've built a pilot in Ghana where we are seeing some good results of current marketing efforts. And we have also built a project in Tanzania and Mozambique, although in Mozambique we found the market too difficult to proceed. Next month we're starting marketing and market testing in Kenya as well, because Kenya would be probably a good market for us to expand from, since we already have the operations and the supply chain in Uganda. So that is a bit of the business behind it. We have a range of standard models, which we have fully worked out, like in terms of drawing sets, technically, for which clients do not have to pay any architectural fees because we invested in them. And those, like for small studio homes, we start from currently, this is an outdated price, but currently start from core and shelf 31 million Ugandan shillings. So that's around $8,000, I would say. Average models range between $10,000 and $30,000 for the Ugandan markets. And as I mentioned, we have around, I think, 20 projects completed in Uganda, mostly around Kampala, but also some in the west, some in West Nile in the north. Made the school interactive map recently, which you can find on the website if you're interested. And here's our team. Actually, we are headquartered in Bugolobi, like 2 kilometers away from here, even though it took more than half an hour to reach. But so we're just around the block. If you're interested in seeing a show model, then you're always welcome. During office hours, you can just visit us at Venture Labs to see the show home and meet someone of our team that can tell a bit more about it if you're interested. So we are vertically integrated as a company and as a team, because especially if you're introducing a new concept in a new market, it's important for the feasibility, for the quality control, etc. That all parts of the value chain of the construction are done by us, even though we hope to move towards a partnership model where maybe sales or production can be done by external building partners or whatever. Also to move towards that scalability. But for now, we're still in Uganda, establishing the blueprints on how to build that ecosystem around prefab timber. Then moving forward, we can hopefully partner up with partners to scale up the capacity faster. And we are very proud, by the way, of the team diversity. Most of our team is based in sub-Saharan Africa, by the way. Some people in the global team that are working on business development, engineering, and although a large part of the team here you see is based in Kampala. Then a little bit on impact. I already mentioned the CO2 reduction, which is a combination of the carbon storage and the carbon substitution, amounting to around 25 tons of CO2 avoided or plus stored in total per average home. 20 jobs created per average home, which can house around 5 people. We have an interesting way of advocating the advantage of bio-based construction for sustainable forestry, because a lot of people ask, is this not causing deforestation? No, it's actually the opposite. If you create a sustainable ecosystem around timber construction, and you make sure that it's sourced from sustainable forestry, you're actually going to increase the demand for those plantation forests and sustainably managed forests around, which is great because the sustainable forestry sector in Uganda is already good, but it still needs more demand to thrive. So we're actually generating that demand, and increasing the forestry sector is great for the economy locally, because it's creating green jobs out of urbanized settings. So it's rather creating green jobs on the countryside. So it's also a local driver of economy, of jobs, and you actually make sure that you sustain the forest area. So we calculated that for an average home, around 7,000 square meters of forest are sustained for a year within sustainable yields. So not harvesting more than is growing. And I mentioned the carbon impact. I'm not going to elaborate on the slides for the sake of time. And then moving into from the sustainability advantages of our approach into the prefabrication advantages. I just made a list this morning of the things I could come up with that you have as an advantage of working in a factory or a workshop, prefabricating it. You're not disturbed by the weather. In countries which have a rainy season, that means that throughout the rainy season you can just keep prefabricating. And since the placement on site is only taking a few days, plan that in did I push a mute button or? Okay, hope you can hear me now, online folks. And I hope you could at least hear a part of the story before, otherwise you've missed most of it. which would be unfortunate. I was saying here's a view into the kitchen of Easy House, and this is our old workshop. And now we have a much bigger factory, but still the capital expenditure we have put in it is very minimal as compared to, of course, you could invest a lot in automation and in mechanization, or like cutting robots and nailing robots and whatever. But we have developed an approach where you can actually, with relatively low capital expenditure, set up a factory. And since in economic context of Uganda, the labor cost versus the material cost is much lower, you don't have to economize on labor. You rather create more jobs. So it makes less sense to invest in automation. Rather, you would invest in just having a good labor pool, and with very relatively simple equipment, you can prefabricate the frames, which you see going on here. Just a set of power tools suffices. And you see a floor frame being manufactured, tong-improved planks. This was actually a makeshift prefab station outside in a refugee camp in West Nile. We just put up a tarpaulin and made our own workstation. Basically, within a day, that basic setup was made, and that actually makes it easy to also prefabricate close to the very location that the house was up. So then, after making these frames from the factory, they are transported on a standard flatbed truck and transported to site. On site, the foundation has already been prepared, which in our case is a very simple block foundation. We use precast blocks, which are around 30 by 30 centimeters and variable heights depending on the slope of the location. And then the entire structure is, well, the timber floor frames are put on these blocks. The floor frames themselves are structurally strong enough that they only need support on the corners. And yeah, then of course, after putting up the timber floors, you start erecting the exterior walls, and you don't need heavy equipment for that. You don't need cranes or whatever. It's all the frames are designed in a way that they can be transported with simple trucks, can be lifted around with the building teams themselves. 4 to 6 people are enough to lift even the roof frames, which also saves a lot of cost, of course, in not having to bring in heavy equipment or long-range cranes. And then, of course, after putting up the exterior walls, everything is being leveled, and yeah. And then we put up the roof frames. We also prefabricate the roofs, and yeah, in mostly usually in 2 days, the entire core and shell is put up, and then the roof sheets can go up, and you have a waterproof envelope within 3 days generally. And then the finishing starts, which is paintworks, but also some small carpentry sticks, things like putting skirts or skirtings on the walls, maybe making the pergola, putting the fascia boards. That's basically it. That takes around 2 weeks. Of course, integrating electricity and plumbing as well. And then the entire construction process from start prefabrication to project completion can be done within 6 weeks. So we say to clients, from once you sign the contract to project completion, that's 3 to 4 months, to give us a bit of time for procurement and for site plans and so on. But the actual construction process takes place within 4 to 6 weeks. So very fast, I would say. That's it for now. Thanks.
Felix will speak, and then after that we'll have a joint Q&A session. We'll bring them together.
Got to do my live demonstration, by the way. Didn't bring it for nothing. I did want to show you some of the basics of our prefab. So that will take 2 more minutes. I hope that's okay.
Yeah.
So we have a Makita impact driver, 18-volt battery system, a bit connector, a bit holder, and a Torx bit. These are Torx screws, specifically engineered for timber construction. I can let them go around. These screws you don't find on the local market, but they are imported from Europe. And you can see you can pass them around some sites. This is actually part of the quality assurance of the prefabrication and also of the circularity of the concept. Using good screws is critical in like if you use poor quality screws, of course, structurally you will not be able to ensure the structural integrity of the home. But also screws might snap and it becomes very hard to take things apart. But with good quality screws, I have a mock-up of a wall here. I think it's nice to show. You can test it with this, but like it takes only remove the. This is also showing the circularity. Right. So now you have the top batten of the wall. This would be the outside where the facade cladding is put on, and on the inside you would put a plywood. Inside you can put insulation if you want, if the location requires it. And then this as a mini frame, you would bring it, erect it, connect it to the next frame, and so forth. And of course, if something is damaged or if you want to increment your house with an extra bedroom, just remove these screws, bring in some extra frames or whatever, and put it back together. Yeah, in a matter of minutes. So yeah, that's always
outstanding.
together later, but that demonstration.
Thanks again. Yeah, so our third speaker of the day, third and final speaker, is Felix Holland, who is from here at Localworks. A short bio about Felix. Some of you might already know him, but Felix is a qualified architect registered in Germany and Uganda with a range of experiences in design and the realization of bespoke architectural projects in East Africa. He is the principal director of architecture studio FH Architects in Uganda, and he is an integral part of Localworks, which is a multidisciplinary design and build collaborative, which is where you are today. That specializes in the design and realization of green architecture in East Africa. As an established group of designers, Localworks has over the years delivered a number of sustainably designed projects, often located in remote parts of the country, and characterized by a deep love for local materials, a site-sensitive approach, and a hunger for experiment. That was a quick introduction. I will hand over to
Thank you and good evening, everyone. I hope people online can hear me. And if they couldn't hear Wolf, we have to ask Wolf to re-record this presentation because that would be terrible if they couldn't. I just click this away. So I'm going to talk about a specific proposal within this whole prefab realm. We have now listened to one very interesting project based on bamboo. We have listened to a second one that's timber-based, that's specifically interested in housing, and that's essentially targeting, you could say, the private sector. And I'm now going to make a proposal for a rather similar technology, timber-based, but specifically targeting schools, targeting the public sector. And it's called EcoPrefab. Where do we need to do this? So those of you who know Localworks know that we have been engaged with school construction for quite a while now. We have built all over the country, used all sorts of different materials and all sorts of different applications. Probably created schools for about 10,000 Ugandan children. Many of them we built with a particular client, the Cotton On Foundation from Australia, who are our longest serving client. And whilst, of course, 10,000 is a nice number and it's something that we are very proud of, you need to see that in a context where, as an absolute minimum, 1.6 million children in primary school age currently do not attend school. Now, they do not only not attend school because there are no school buildings. There are many other reasons why people don't go to school. But I'm yet to see a classroom that's not overcrowded in this country. So the fact that there's a gross lack of classroom is totally evident. Enable, the Belgian development organizations, estimates that currently there's a shortage of about 8,000 schools in Uganda. That means with a typical school of 10 classrooms, a typical single screen school, you're talking about 80,000 classrooms that are missing. The population pyramid of Uganda is also particularly impressive. You see there 9.9 million children currently in that band of primary age. The 1.6 that is we are talking about there are shown in purple. And now look 5 years ahead and you can see how this problem is only going to increase over time. This is sort of a typical image. Many of you who live in Uganda are familiar with this. Hopelessly overcrowded classrooms, very, very poorly built infrastructure. The picture in the middle is actually a project that was probably only about 5 years old by the time we took that photo. And we as engineers and architects were brought in to look at this building and see whether it could be used, and we had to basically structurally condemn it. So in other words, a real issue is quality in construction, those few buildings that are being built. And then lastly, of course, the typical materials are high energy materials, either concrete blocks or fired clay brick, both contributing to climate crisis and deforestation. The graphic on the left you've already seen. In Nishal's presentation, 38% of global carbon emissions are related to construction. About 10% of that is directly related to the material and the transportation of materials within the construction. And then that is in a context where Uganda and the other East African countries have all signed the Paris Agreement and have all committed themselves to reducing their emissions by 25% by 2030. And we sort of put these two things together and think we must find a way of building public infrastructure, badly needed public infrastructure, using regenerative materials. And we need to do this all in a prefab way because there's no other way of scaling. And this is sort of the background to this proposal called EcoPrefab, a green and scalable way of building schools in East Africa. Not something that has to be limited to Uganda, of course. We are working in Uganda because that's our home, but the climate and the sort of socioeconomic conditions are very, very similar in countries like Kenya, Rwanda, Tanzania, etc. So surely a similar technology could also be adopted in other East African or maybe African. How does it work? It is based on a composite frame, a lightweight steel frame with timber panels which act together. That's the core of a composite, that you use two materials and you make them work together. You utilize each of them to its strength and you minimize each of them as much as you can. And we are combining that with lime plaster. So we are actually not exposing the timber. That there's a parallel to base Bahay's technology. We are rendering these buildings from outside. We are using earth as a pigment, and we're using lime, so we're not painting it. We're not using cementitious plaster. And I'll tell you a bit more about that, why we're doing that. The picture you see there are not classrooms, they are teacher accommodation. That's also a very important aspect of school construction. No rural school functions without adequate teacher housing. So we actually started by looking into the teacher housing before we went into the classroom. And this is how a typical classroom will look. We estimate about a 75% reduced carbon footprint compared to conventional construction methods. And what is important, very similar to the two speakers before me, when we talk of EcoPrefab or of prefab generally, we're not talking about temporary, we're not talking about mobile and movable, we're talking about permanent buildings that are made with prefabrication technology. And also I think the architecture wants to express that. And this is how it works. We are prefabricating wall panels. They tend to be about 2 meters wide, and we install them on top of a concrete upstand. We then fill in this wall panel with a block that we are pressing out of sawdust and lime. And then you see on the picture on the right how that is combined with a primary steel frame, which has one very light column in each corner and a steel ring beam that ties it all together. Our foundations are made out of stone. This is really for 2 reasons. On one hand, stone is a zero carbon material that is available in most parts of the country. Number 2, stone is very, very good in dealing with moisture that is coming from below. And that's, of course, something you want to really avoid in timber construction. But then you can also see in the middle photo that we are having another little spacer detail that jacks up the timber off this concrete upstand. And then on the picture on the right, you see how this sawdust line panel stands in that wall. And then there's a chicken mesh on both sides, and then there's lime plaster applied in 3 layers. The roof is a ordinary metal sheet roof. The floor is a concrete floor, very, very thin and placed on a stone bed. And then our windows and doors are made of steel frames with timber plank infill. This is for the classrooms. For the teacher housing, you've seen there some glass windows. But for the classrooms, we are actually proposing not to use any glass. All the timber is treated. All the timber is certified. Borax and boric acid is what we are using, very similar to what Michal was talking about. And on the right, you now see how we are encapsulating these walls on both sides in lime plaster. The encapsulation has really various reasons. One key reason is that any treated timber loses its treatment over time. Borax and boric acid has a tendency of, with time, basically with exposure to rain and to air, to evaporate and to lose its efficiency. And the encapsulation of the wall in lime plaster helps preventing that. Borax and boric acid is also a fire retardant, and again, encapsulating and retaining that treatment within the wall improves the fire performance. And lastly, and that is not to be overlooked, we've heard already about the cultural connotations of natural materials. It is intended by the inventor not to show the timber, not to show the structural timber. If you speak to typical occupants of our teacher housing and you tell them that this is a timber house, they will not believe you because it looks and feels like a masonry house. Is there enough timber in Uganda to build 8,000 schools? That's a typical question that we are getting very much. I'm sure you also get that same question. Those questions, is it good to use timber and are we not deforesting the country, etc.? So we did a little analysis. We found out that one classroom will require 5.6 eucalyptus trees and 2.2 pine trees. We're using pine in the wall and eucalyptus in the roof and in the windows. And then we compared that just only to Busoga forestry. There are many other plantations and forestry companies in Uganda, but there's only one currently that is properly certified. And what you see in that little statistic is that if Wolf was not so successful, then Busoga forestry could sustain 4,000 classrooms per year, or could produce enough timber for 4,000 classrooms per year. And the bottleneck is actually in the eucalyptus, not in the pine. They are very good on pine. They have loads of pine. They have not so much eucalyptus. But we are quite confident that, with time, if this thing is taking off, there will be many other producers as well who can supply us with this required timber. These are the different building types that are available. What we are trying to cover at this stage, which is kind of the first step, is to meet the needs of a typical day school in rural Uganda. So these are single-story buildings. There's no dormitories. These are pure classrooms. There are teacher accommodations in 3 different configurations. There's a school administration block. There is a kitchen and there is a toilet. Those are the typical 9 buildings that your average school requires. With time, we have plans to add more buildings to it, to cater for the need of a secondary school, which tend to have science labs, which tend to need boarding facilities, etc. But this is what we are going to start with. And this is also important, the cost. Just like in housing, in public infrastructure, cost is absolutely essential, more important than anything else, to be honest. When you talk to a typical representative of the Ministry of Education or of a typical international funding agency, the first and the last thing they're interested in is the cost. And the way we are currently projecting this cost for a typical classroom is that we are ever so slightly below what we are calling the seed school classroom. That is a World Bank funded project that Uganda is just rolling out. In conventional construction with concrete blocks and cement-based plaster and paint. And we're about 5% below that, which is something that we are very proud of. Of course, time-wise, we are still in the product development, so we are not as far as Easy Housing, who already have the actual experience. We have built some prototypes. We are still working on further prototypes, but the plan is at least to condense a school construction into 5 months. You put that into sort of comparison with a typical school that we currently build in our normal way, we are easily there 15 to 18 months. So that's a substantial reduction in time, and reduction in time is of course also a reduction in cost. This is our rollout as a company where we are. We broke our program down into 3 blocks, teacher housing. We did that first because we had a specific client who needed 52 units. So we fast-tracked the development of the teacher housing. You see a photo there on the right of one of these buildings. These buildings are in Rango district, about 4 hours drive. Whoever wants to go and see it can go and see them. And we are now in a situation where we are just about to start on the pilot for a classroom block. And we are proceeding with the designs of the remaining 3 admin, kitchen, and toilet building. And now there's just a few images, a few more photos to show you the process. You see on the left, site grading, foundations, stone packing, and then our in-situ concrete upstand. We have plans to replace that in-situ concrete upstand with a precast concrete upstand because it is very laborious and takes ages to do. And it's very difficult to get precise. So it's something that we want to invest in. And then you see how these frames are being erected, the composite system, steel and timber. Our wall panels arrive on site with the windows and doors already installed. So there's a further time saving there. And then we roof these structures. We press these blocks on site currently. That's also something that we can look at to do in a factory setting. Some of the conduiting for M&E is also already pre-installed into these panels. And then we fill in these blocks, put the chicken mesh over it, and start the rather laborious plastering process. We use local earth to pigment, so there's an element of in situ work that needs to be done before we can do the final plaster application. And then for the teacher housing, there's an element of built-in furniture, all of which is also prefabricated. That is considerably simpler in classrooms, of course, where you have almost no furniture at all. Thank you very much. Wolf, you now need to come here.
What do you want? I'm just gonna put the seat up for you there so that you can. Or people. Yeah.
It's still visible for them.
All right, so I will just like hand over to the audience, I think, to ask. I think now that both Felix and Wolf have spoken, we can hand over, yes, to people who are in the room if you have questions you'd like to ask. And then we also, if there are people online who would like to as well, we can do that. So we'll just.
Hi again, my name is Sophie. I have a couple questions. Mostly towards Felix and maybe one for you, Wolf. One is general. It's about thermal insulation. Well, I guess to Wolf first. How are you insulating these homes considering heat in Uganda? I noticed you have a plywood finish on top of the timber. In most cases, there are times when we do need to insulate. So I'm wondering, how does that compare to masonry in terms of resistance? Thermal resistance. I guess the same question goes to Felix, because you said you're using, what's the detail again? Sawdust, I think, that particular detail. How does that compare to masonry? If I used 8-inch block wall compared to that, should I continue? Well, that's the first one here. Yeah. Oh.
So the way we currently build in, at least in central Uganda, is very lightweight. I think we have the lowest thermal mass of all the different concepts that we have seen this evening, because in relatively moderate climate, like around Kampala, we don't even put insulation in the exterior walls. We do put insulation, reflective insulation, below the roof sheets, so that during the daytime, the irradiance is reflected and the heat doesn't come through the roof so much. We don't have to put any insulation in exterior walls, actually. I live in my own easy home, which is near Entebbe. So I've been testing it myself over the past year, and it's very comfortable. Actually, there's not been you can even get a little bit chilly on very cold days, but then if you close curtains or whatever, keep everything closed, it's very comfortable inside. I think it's different when you go to the far north, where day temperatures can be very high. Then the low thermal mass is actually a disadvantage, especially if you use your interior during daytime. So if you would use it as an office or something, then it would be a challenge. However, the advantage you have with lightweight structures, that at nighttime, when you actually want the home to cool down, it cools down much faster than a brick structure, because it doesn't have the thermal mass So you'll find when you go to bed at 10 p.m., the home will have interior. Sorry, the interior temperature will already have adjusted to a large part to the outside temperature. So in that sense, like a timber frame is actually very comfortable. If you would go to colder conditions, like maybe if we move into Kenya, like in the central parts, in the highlands, it can be quite cold, then you would put insulation in the exterior walls as well. But when it comes to heat regulation, I think another important aspect is in design, like having proper overhangs of at least 0.5 meter, which we have. The sun orientation of the house, of course, matters, and having cross ventilation openings above the windows, and having that designed properly is really an important part of the thermal comfort as well. I'll give it to you to address it for.
Yeah, as Wolf has said, it's you can approach tropical climate in various ways. You can go lightweight or mass. Our system is actually based on creating thermal mass and on having a very efficient reflective roof. As he has said, if you first and foremost you want to reflect the sun energy away, and you want to orientate your building correctly. And then in most climates, we found that creating thermal mass is beneficial to the indoor climate. These buildings are very, very comfortable. So the staff housing feels just like it feels actually more comfortable than a typical cement block building. But that is not necessarily because of the sawdust infill. That, in my view, is because of the lime plaster. Lime plaster is allowing humidity to pass through the wall. It's like the human skin. So therefore, the air inside is always fresh and comfortable, of course, combined with good cross ventilation. Classrooms are particularly light. You saw that. The classrooms are now really daytime use. So there we're not worried about, let's say, coldness at night. And we have really maximized on air and light. The other big reason for us, really, I mentioned that in my talk, the other reason to go with thermal mass rather than with lightweight is that we are specifically competing with blocks and bricks and with a perception of timber as a non-durable, lightweight, inferior material. So we are trying to address that by going for mass.
Thank you for the presentations. My name is Jesse. My question goes to Wolf. I'm curious about the very distinct glossy finish on the timber. Does it have any other role beyond an aesthetic finish? Is it important in protecting the exposed wood or? Yes.
Well, it's just a client choice. We have different cladding options. In one of our homes, we have actually applied cement boards on the outside and plastered them in also in a reddish colored plaster. You can even leave your timber untreated, and then it turns light gray through UV exposure. I think a lot of our clients just like the varnished look, and that's why they choose it. But yeah, we also have. You could also paint it in a color, like we have a white painted or whatever works, or the plastered look. So there's a variation of options for that. And actually, if you would go to a more densely, like if you would create a cluster of homes, for example, then if you're within 5 meters or so, then you actually have to have fire retardant facade cladding. So then a plastered cement board facade would be probably compulsory or preferable for that matter. Yeah.
Question which deals about modularity of your different designs. Now, when you had your demonstration, you said you can just put a bedroom at a bedroom basically. What's the level of modularity and also custom made wishes from clients you are able to integrate into your system. How do you deal with that technologically, also in terms of developing the product?
Yeah, it's a good question, and also here we try to balance an approach between bespoke architecture and scalability. So we have what we call maybe a mass customization approach, where we can customize floor plans to clients that have their own design wishes, but we stick within our own grid and typologies. So we basically have a few different models, and from these models you can extrude them, but only in the width of the building. So the depth of the building, which is also basically defining the roof structure. So we have a monopitch roof at around 5 meters deep. We have a gable roof of 7.5 and of 10 meters deep, and a clerestory of 8.5 meters deep. And as long as you stay within that grid, the interior walls are non-structural, at least most of them. So our architects can actually play around, customize that, and create custom floor plans, while for us technically and structurally nothing much changes. I think that's we developed that approach over the past 6 months, and that's been really effective also in engaging clients that do want a certain level of architecture, but not going through the fully bespoke architectural costs, because those would be much higher than what we so we can actually offer that quite affordably. And one more thing I wanted to say about that. In our standard models, which you can find on the website, we have the catalog with standard floor plans. You'll find within those standardized typologies variations of floor plans that are incremented versions of the smaller ones. So those could be going from 1 bedroom to 3 bedroom versions, for example. Although in practice, we haven't, but maybe in the future we'll have clients that actually ask for that. We'll see.
Thank you, Wolf and Felix. My name is Guy once again. I have a couple of questions to Wolf particularly. The first one regarding the easy homes is whether these buildings have been fire rated to provide assurance to the potential clients about the fire performance. Then also there's a concern on the lateral resistance, set forces like wind. How are these structures braced against those lateral loads? Then the buildings look like semi-permanent, I don't know. Could you elaborate on the service life? Like semi-permanent, basically something we usually design for, say, 50-year service life. So maybe you could elaborate more on the service life of these structures. Then lastly, in your presentation, you showed these buildings have timber floors. How are you dealing with spaces like bathrooms that are prone to exposure to water?
Yeah, thanks. And I think good questions. Let me try to answer them briefly. In terms of fire, all our current projects are detached single-story structures, which count as a single fire compartment. So there's no regulation in terms of fire hazards to other fire compartments, which makes it easier. If you would do multi-story, like apartments or semi-detached or terraced housing, then of course you have to integrate for the building code. You have to integrate the same sort of fire separation walls that that we also saw in the presentation at the start. In modular timber construction in the Netherlands, with my company, with Sustainer, we've done a lot of fire development for modular apartment buildings in full and mass timber, which is a very expensive development. You will have to add a lot of layers like plasterboard or other fire retardant layers. But in this case, for single-story detached housing, since it's a single fire compartment, you don't need to add any fire proofing. And in fact, if you look at the United States, where I think over 50% of all residential buildings are out of prefab timber, or at least out of timber. You see that it's not really a problem. You just have to be careful not, setting your house on fire. But most fires in homes actually originate from either short circuiting of bad appliances or from candles or cooking, and then the fire starts in your furniture. So in a fire scenario, the only difference is that you'll have your brick wall still standing after the fire. But yeah, so you have to wonder what the difference then would be. With the timber structure, you would lose it in a full fire scenario, of course. But yeah, it's about fire prevention and fire safety. Of course, that would change if you go to different building typologies like apartment blocks, which definitely is possible. Then you start to add what I mentioned: plasterboard, fire retardant paints, etc. Secondly was service life or durability of the homes. If you look at prefab timber and timber structures across the world, then most of them survive for centuries, and there is no reason that would be less in Uganda. The timber we use is pressure treated against termites, fungus, etc. So our projected lifetime is at least 100 years. And thirdly, what was the third point again? Wind, right? Yeah. In our frames, we put bracing. Both the plywood serves as a shear force or stability wall, as well as the diagonal braces in the frames that we put. Yeah. Sorry? Bathroom closed. That one. Yes. In bathrooms, we first put a plastic membrane, then a cement board, which is the adhesive for any tiling, and then the tiles are put on. So any water or humidity cannot penetrate through the plastic membrane and the tiling layers.
Should be great. All right.
Thank you so much for these presentations. I think I have two questions. One that is a reinforcement on like the treatment. We saw with architect Felix how rendering is one of the ways that they are protecting the timber, but I'm still invested in the type of treatment, because he said that some of these treatments like borax, they eventually evaporate if the timber is exposed. And one of the things that the electric poles, they really go through a rigorous treatment process with like infusions and everything, and yet eventually the termite still eats that timber. So, and they have to make replacements, and now they've actually moved on to make concrete poles instead, because they're like, this is more long lasting. So for you, how have you dealt with that? I've only seen the timber houses in universities which were built approximately in the 60s and they're still standing. And I still don't know what type of treatment they've used, but it's all black. So the color is maintained. So I'm invested in that. And then the second question is on the estimated cost of a unit. It was about 30,000. And I'm asking, is that because it's not yet scaled greatly, or is that going to be the approximate price? Because it's almost approximately equivalent to what is being spent on like an ordinary Ugandan's house that is made out of all these brick, mortar. So, and yet most times when we are pushing for bioconstruction, sometimes maybe we are like, oh yeah, this is going to be like low cost for you and everything. So if I'm going to construct a 3-bedroom unit at the same price that is for the normal building method, like I'm interested to know how you have dealt with that. Thank you.
Afraid.
Handle with care. Yeah. Let me start with the price point. So indeed, we built for core and shell, including basic finishings, around $300 to $350, including VAT, per square meter, which is below or around the same price that traditional contractors would charge in brick and mortar, which I think is great because it's at least it's not more expensive, yet you get a higher quality and much more sustainable products. So you could rather look at it from the other side. And yeah, we of course, like for that price point, I think having all these benefits, I think that makes a very strong position for us in Uganda, at least. In some countries, it's more difficult because the timber will be more expensive. Uganda, because it has such an extensive and well-established sustainable forestry sector, we can actually operate around or even above, below market average. Then regarding the pressure treatment, we use CCA treatment, which is the same treatment you see on the electricity poles. Environmentally, it's not the greatest solution, but as long as you make sure that you have a proper processing, dust collection, the good thing about it is that it's a salt solution that is impregnated under high pressure in the kiln-dried timber. So the salts like penetrate through into the core of the fibers of the wood, and they don't wash out. The reason why you see electricity poles maybe after several decades they might become faulty is that because the salts might wash out on the surface, and that's where then slowly there might be some insect attack. But in properly detailed construction, the timber structure is entirely suspended from the ground floor. It doesn't get exposed to rain so much. And of course, it's also painted or varnished. And if you maintain that well and you inspect the structure, there is no reason to why the treatment would wash off. So in fact, we know that even electricity poles that are fully exposed to weather conditions will still last multiple decades. If you have a construction where you have good technical details, rain protection, maintenance, etc., then we are confident that it will last at least 100 years, we think. And looking at the professor homes at the Makerere University campus, those were constructed in 1931. They were not pressure treated. They're almost 100 years already. They are very similar in the technical details as they also have a suspended floor on small concrete columns. And I think that timber is maybe only superficially treated or not even treated. I think it was, it's not plantation wood. I think they were built with hardwood, which is even more resistant naturally against termites and insects and fungus. But we use softwood, we use Pinus caribea, which is more affordable, faster, easier to build with, but it requires a little bit more handling treatments to make sure that the lifespan is good. I think those were your main points. You do borax, right?
Yeah, we do borax. Borax is also a chemical, and it's also environmentally not ideal, but it is. We consider it as still the least of the bad solutions. And I think I've explained otherwise how we do it, how we encapsulate it, and why we do that. So I don't think I need to continue.
Thank you so much for your presentation. I think it was very informative, both of you. My question is more about what wasn't spoken about. Since we were talking about prefab timber, I wanted to know if either Localworks or Easy Housing ever uses glulam timber for its obvious the manipulation and the flexibility of design. And if not, is that because of our limits in technology, or is it just less sustainable than I thought, or is it an economical thing, and is there a future for it in our country?
Definitely think there is. The reason that we are not yet using it is because it's not yet available, to my knowledge. I know that Fair Ventures is working on it. And as and when it becomes available, we'll be the first ones to use it on our bespoke side, as in on our bespoke project. I think when you talk of prefab, we are now really talking about squeezing costs and being hyper efficient. And I would not believe that glulam is going to be competitive for a long time. I think it is going to be a very interesting material for some applications, for larger spans, for more expressive architectural shapes, etc., but not for classrooms, in my view.
Yeah, it's mostly for public buildings. So Simon Bosch, when he was working at Fair Ventures last year, developing the rooftop structure on Crown House and Kampala Road, the Fair Ventures Timber Expo, uses glulam as spans for the roof structure, which they press themselves in partnership with Busoga Forestry. So that is a cool example of how it was piloted here. In general, I would say mass timber is just very expensive, whether it's glulam, cross-laminated timber, or laminated veneer lumber. They can all be used in great ways in either public buildings or apartment towers. As you can also see, especially in Europe, we have great examples of high-rise timber with mass timber or engineered timber. But in East Africa, I think it's important to first establish an ecosystem of construction with like normal bio-based materials. And then from there on, we can move forward to maybe multi-story and mass timber blocks. A few players are trying this around East Africa. The forestry sector is there, so it would be very nice if, for example, Tanzania had investment into a mass timber production plant. But for now, even the larger forestry players are still trying to raise funds to just professional or to modernize their normal sawmill facilities and so on. So that's the first priority for their investments.
Okay. Thank you. My question is more towards, let's say, what's your experience with public buildings, especially, let's say, public officials? I can give an example. Let's say, for example, the NFA has their headquarters just here in Bugolobi. They have a nice timber structure. They also have nice timber structures scattered around the country, in Fort Portal, mainly in Western Uganda. However, when it's time to do renovations or any building upgrades, they just, take away the timber buildings and, insist on masonry. So I don't know what's your experience with, let's say, pushing these ideas to, especially, let's say, public schools, public officials, and things like that.
An uphill task, and we are in the middle of it. There's a lot of conviction that we have to do. But I would say the overall, the first reaction is actually quite positive because of the scalability and because of the price, not because of the material. Climate change is not something that any official of this government is remotely interested in. They have never even heard about it. But what they're interested in is 5% less cost and 3 times faster construction, because they're all aware of the insurmountable task that what 8,000 schools need practically. They know how they can maybe build 100 schools with World Bank funding, and that takes 4 years. but how to build 8,000 schools is basically unthinkable. And therefore, I would say the first reaction is actually reasonably positive. And then it is about building pilots and proving the concepts. That's what we now do. We are actually trying to raise funds in the moment to build pilots, because until ministry officials can touch these things and see them in operation, we are not going to convince anyone. It's actually easier to convince the donors, the funding agencies, but the problem is that they only fund stuff that the ministry guys want. So we have to go first through the ministry and convince them. By the way, when I talk about ministry, it does not mean that we are not also interested in many NGOs. There are lots of NGOs building schools in this country, and they are naturally much more open-minded. It's just that their programs are normally much, much smaller, but that's also definitely a market for us. But it's definitely an uphill battle. I'm sure you fight the same.
Yeah, although in some spots, I think, take for example the Timber Expo of Fair Ventures, they did go through a permitting process with KCCA. I think it was not easy, but it was approved. National Housing Uganda reached out to us to see if we could co-develop a proposition of affordable, sustainable housing on land positions of National Housing, which I hope we can move forward to a pilot project with them, which would also be a nice way of scaling up, because National Housing is also looking for like more sustainable and affordable solutions than they currently offer, I think. So you do see changes, and I think the entire ecosystem around bio-based construction is slowly shifting. Uganda Society of Architects is trying to promote it more in their ecosystem as well, I think. But yeah, we've been hooked up to cement for decades. So it will take probably a few decades to bring the same level of knowledge across all sector players to, and then I would already be happy if we reach 10% bio-based construction by 2030, hopefully a bit more even, but I think it will take us several decades before bio-based and or alternative building materials will have gone through that transition. A bit similar, I would say, to the energy transition, where fossil energy will slowly be phased out and renewables will come in. Hopefully we make that we do that fast enough, then we'll be okay.
Hello, good evening. I have two questions. One is mainly just something I'm curious about. You've mentioned that treatment is with borax and boric acid, and you said it is not the best solution. Which one is the best, and why aren't we using it? It's just a question. I'm just curious. Then the second one is for Felix. You said with regards to the prototyping, I know right now, at least we've had issues of fires and safety hazards for boarding sections in schools. I'm just curious, have you thought of the prototyping yet? Because I know it's a big issue currently with the ministry, and it could be an entryway for you to start talking to them. Have you thought about it? What are your thoughts yet thus far?
I said borax and boric acid is not ideal. I don't think there is an ideal form of treatment. I think every material has its strengths and weaknesses, and you need to weigh them up against each other and find the correct solution. What is important for us is also the indoor health of a building. So one of the big advantages that borax and boric acid has is that it does not affect the indoor health and the healthy environment that we want to create in these buildings, which I think the pressure treatment, the conventional pressure treatment, does not do. Fire, of course, is a big issue. You've noted that we don't do dormitory buildings. There's a big reason for that. A building generally that is used during daytime has completely different considerations than buildings that are being used at nighttime. When it comes to classroom buildings on a single-story arrangement with 2 doors, you are now largely looking at how long does it take to evacuate this building in an event of fire. And you can imagine that a room of 50 square meters with 50 children in it with 2 doors we are talking minutes. Yeah. When it comes to the roof structure of our buildings, they are actually exactly identical to a conventional classroom. Yeah, they have roof trusses and they have metal sheets, like many other school buildings. You know, conventionally you either use timber or use steel for these roofs, but most primary schools in the village are made out of timber trusses, so there's actually no difference at all. And then the walls, I've already mentioned, our walls are encapsulated, so it takes a long time for them to actually catch fire. And as I say, if they do, your primary interest is saving lives, not saving infrastructure. That, however, is not something that a typical ministry official agrees with. So, you know, for them, it's really like, oh my God, are we going to use a classroom? And they think, yeah, but you're going to build 8,000, and then you're losing one in 20 years. That's probably still kind of acceptable compared to the benefits that you have you've gotten through this type of construction. I think fire detection is the other very important aspect. I think you didn't mention it, but I think when you deal with rooms in which you sleep, and when you, let's say, have the risk of poor wiring and furniture catching fire, I think fire detection is a very simple and very important aspect of timber construction as well.
Yeah, we give a smoke. Every client, we give a smoke detector and a fire extinguisher as a sort of bonus, just as an extra reassurance. Yeah. Which in most cases actually does the fire prevention. Right.
Thank you for presentation. My name is Anthony. I have a quick question about the classrooms and their sound isolation and like quality. I guess the classrooms are of course very loud, and how this technology works with sound. Yeah, acoustics. Yeah.
Yeah, just one more question for, I think, each person. For Wolf, you talked about going back to the insulation thing. Since you're moving to Kenya, right? Temperature is different. What kind of insulation are you looking at, especially sustainable wise? Then for Felix, this is more of detail. I'm curious, how do you feel that gap where the floor plate would be? What you filled as a steel, what happens in that area? Do you feel it? If you don't feel it, what happens in regard to the mass insulation? And the last one, I'm curious, what inspired that clean out detail that you did on the gutters?
Oh, sorry. So the first question is about acoustic. So there's two aspects to this. What happens in these classrooms when it rains? It's mayhem. It's basically, they are unusable. Like any other local school, they are basically unusable during rain, and you sit there, kids do coursework, paperwork, and you wait for the rain to stop. The good thing in Uganda, rains tend to be quite fast. So 45 minutes later, rains are gone, windows are being opened again, and class continues. We are pushing the price limit here. We're trying to build for $250. Forget the ceiling, forget insulation. It's just not affordable. So basically, you just take that, you accept that. Otherwise, they've behaved very well. You've noticed that these walls are generally quite textured. If you've seen it on the images, lots of windows, lots of high level ventilation. So there is not very much sort of, there's enough destruction and texture in the walls to not create an echo effect or something like that. So it's reasonably comfortable. And between two glasses, the walls are, you know, these blocks that we are making are very, very good. They are actually combining thermal mass with a very porous material, which is sawdust. So they are behaving very, very well. We've noticed that in the teachers' accommodation, especially where you have one unit next to the other. So there's no issue with sound traveling. I will answer your question and then I will hand over. Detailing, that gap is basically filled with that lime plaster that we're doing. Yeah? But there is the joint at the bottom that we are then filling with a bit of sealant because we are trying, of course, to prevent moisture moving up. And so there's a small gap that we then later fill with a sealant. And the downpipe detail, I wish Alan was here, who is our downpipe person. As in, you mean that little T? You know, that is really about a clean out. So basically, this is actually a normal T profile. You can open it, and then if stuff gets in and blocks that downpipe, you can very easily remove it from without having to climb on the roof. I'll give you Alan's contact, and you can ask him what inspired him.
Yeah, and then about insulation. Currently, we insulate between partition walls, also for acoustics, actually. The interior walls are insulated with it's frankly just ordinary glass wool. We've done other insulation materials. I've used papyrus as a bio-based insulation, which actually works quite nicely. Dried papyrus. I think your sawdust infill is also a good wood wool type of insulator, both for thermal performance as well as for acoustics. I think those are very good, but it's also, it's not available everywhere. Even things like glass wool or rock wool have to be imported, so it's not easy. But then again, if you compare it to brick and mortar house, a brick really doesn't insulate at all. So the baseline is also very easy to beat, I would say. Yeah.
Let me just stand here. So thank you everyone for joining us. Maybe I'll stand so that today I think we're going to conclude. We're almost on time. What did I need to say? Most of the questions online are about how to contact the speakers. So I think we will share their contacts maybe via a newsletter that we have, or in the recording on the YouTube channel. We can also post the links maybe to contact both of them and Nishal as well. And then another place, I think that's it, maybe our social media, Instagram or things like that. So yes, thank you to the two of you for joining us, and Nishal earlier, you might see this in the recording. And if anyone wants to get in touch with more questions, you're welcome to do that on the same networks that I've just explained. We have local talks 4 times a year, as I said in the beginning, so we'll have another one in December, which you're all welcome to join us online or in person as you wish. I think that's everything. We will upload the recording as soon as possible so that people can continue the conversation.